Hello everyone, this is my first time here in this PocketQube conference and doing this, any kind of presentations about my student association ever, so I'm sorry if my voice is a little trembling. I've come here to talk about UPC Space Program Association. That is I'm the current coordinator of this association that is based in Terrassa, that's basically in Spain. And I want to talk about our latest project related to the pico and nanosatellite technologies. Okay, so first of all, just a brief explanation of who we are and what we do. We are a student association in Spain, and we historically had 5 projects. But now we just have 4 that are ongoing. First of all, there's Eldora, that's based on drones and UAVs, and they're gonna present a drone for the student air race in Germany in 2 years, so 2025. Then we got Ares, that it's a rocketry team. They're just gonna present a 2-stage rocket to the EUROC 2025. And the most famous of our projects, it's GRASS. There is a planetary exploration rover that is competing in the European Rover Challenge in Poland every year. And finally, the main project today is HORUS. It's about picosatellites and nanosatellites. So a little overview of HORUS. It's the newest project in the association. It started during the pandemic, and it mainly focused the first year into study and develop PocketQube and picosatellite technologies, and that included just include 3 of them. But the first one was a laser communication between 2 CubeSats, and this project was later took off. Taken by university research development group, that is Platoon, and they are currently just doing it more professionally in case they can make it. And then we had the altitude control simulation using MATLAB and Simulink. We are basically capable to simulate what's going to be the behavior that our one unit CubeSat is capable or will be experimenting in outer space. We had it like modular, and it started really simple, but now it's being, I don't know how to say it, but upgraded through battery modules and other kind of models that have more specific components and properties. For example, if it's 1 unit CubeSat, then we implemented the 2 unit CubeSat kind of change in the model. And finally, the electrodynamic tether, that's one of the most recent projects that we started, an objective that we wanted to develop. Basically, we saw 2020 horizons objectives and proposals for ESA, and we thought, what about having a greener thruster? It's low thrust, but for a propulsive system for a CubeSat or for a picosatellite, maybe an electrodynamic tether would work. But we stumbled when we decided to find a PocketQube kit that would satisfy our requirements and our problems with the electrodynamic tether. More or less, the tether would be between a range of 3 meters to 5 meters. So we needed a little bigger space than 1.5 PocketQube kit that we were working with. So we decided to, let's just stop the project. We had a deployment system that we had developed but didn't quite work. So we say, stop it there, design a PocketQube kit, and then when you got the PocketQube kit, we design it ourselves, then we will come back to the electrodynamic tether. And finally, that's why we're mostly trying to develop an ultra-low-cost PocketQube kit and make our team members or students throughout the whole university, because we are all spread through Catalonia, so to make these space projects more accessible for them. And this is because also we had a problem, is that most of us found or saw the first PocketQube or CubeSat when we were already nearly graduating the bachelor's. So we were like, why so late in life? So we were like, okay, so let's bring 1-year students or 2-year students in the bachelor's. In Spain, 4 years. And most of our new members, they participated in the CubeSat competition, so they're already motivated and they know what they're doing. So we're basically just bringing space more closer to those students that maybe they're not aerospace, but they're engineers, or they are really motivated to start in the space field. So, well. Why a 3D-printed structure? There's 2 different structures for a PocketQube kit. We would say the PCBs, and then we have the solid structure. And we just chosen these ones to start. It's easier for us students. We have 3 different 3D printers in the university campus, so it's easier for us to start with a solid one, to see and study the standards, the dimensions, and study materials. This is our main focus today. Basically, as we said, we had, later you'll see our sponsors, but we have sponsors with composites and also fibers and PLA filaments. So this is why we also chosen this kind of structure. And well, we are now studying for 1P, 2P, and 3P PocketQube kits, and we are starting with FDMs materials. We are we're looking for fiberglass and PA matrices or PC matrices, but our main problem nowadays is the outgassing that these have. So we're now focusing, because we have 1 bachelor degree thesis studying this kind of materials, but we are going to move on and try also carbon fibers and other kind of composites. But for now, we're just focusing on how to deal with the outgassing problem, because we have been working with UPC Nanosat Lab. They already work with ESA and thrown into space some satellites, and they had the same problem, so maybe we can work with them, and we are being in touch with them in case we can solve these problems. And I would call this slide the TBD, to be defined or to do, because, well, we had our first 3D prototype with deployable solar panels. It's we gave them to the new members or to students that are doing different selectives in the bachelor and the master's, our 2P prototype, and we said, you got this, now design me a deployable solar panel, solar arrays, and this is what they came up with only 3 weeks. So quite successful, I would say, and what we now are going to do is start looking for viable solar cells, and also getting in touch with businesses, or like at Spanish level or European level, that know how to do the PCBs and have worked with what kind of solar cells are they using, because we are a low-budget kind of student association. Our main focus is cost-effectiveness, so we want to see the whole market and see, okay, so what are our options? What is going to make our PocketQube affordable? Because we are not going to lose that. We don't want to lose that point. And then for the onboard computer, we have 4 candidates, and we're going to do some studies around them. We have the SP32, the STM32, we have the Raspberry Pi Pico, and Arduino Nano as ideas. And it depends on the kit, if it's the 1 unit, the 2 unit, or the 3 unit, we're going to decide which to use. And finally, for the power management system, as I said, our most famous project is GRASS. It's the most successful one. So they got a lot of experience for the PCBs and how to make everything work. So basically, we're going to work with them and collaborate within projects so that we can move on. And finally, any of our projects wouldn't be possible if we didn't have our sponsors here. So thank you for your attention, and this is our social medias. So in case you're interested, or do you have any question, just please ask it.
Great presentation. On average, what is the cost of manufacturing your PocketQube kits?
For the moment, it's 0. We haven't started with the electronics part, but as we said, we have sponsors, and the filaments is for all the missions. So basically, we're sponsored in that part.
Anyone else? You were looking for someone else.
No, I started to.
So, are you still looking for materials to send to space, the 3D printing materials?
Yeah.
Okay, then I can tell you 2. There is one called Pool10, but some 3D printers don't have it. And if you're looking for a 3D printer that actually uses lower case, the material is called PC, polycarbonate.
PC carbonate.
PC, yeah, it's called PC. And then the Ultimaker, they can actually print with that material, and then you can actually send it to space. Its outgassing levels are really low, so they qualify all the requirements, so you can use that, and you also use it for.
If you don't mind, I'll just go after that, and I'll take a note. Thank you.
One more? Any other questions? Yes.
Thank you for the great presentation. Just one question about the mechanical properties. I think normally like the printed objects are quite weak. So like I think I suggest to do some vibrational testing, mechanical test, just to be sure that we withstand the load.
We are talking with UPC Nanosat Lab. It's the facility in our faculty in Barcelona that they do have this kind of test, vibration, and they are also sponsored and have a bigger one of that part we have facilities to do this test, don't worry.
So, okay, last.
Looking at this, how do you plan to integrate electronics into this? Is this, can you take this apart, or?
So for the moment, this is just the first mock-up, like to make students familiar with the dimensions. So make sure that they're giving the standard. So you give them the standard, you give both mechanical and electronic one, and you make them, okay, so design me this. And this is the first 2P prototype. It became they were like in the first year of the bachelor. So this is just the main structure so that they can see the dimensions, if it's going to fit, how the space they're going to have, more or less. And I have a mock-up there with a 1.5 that we already had another, an after version that with a 1.5 that we opened, and they could see where the main control board, where the electronics were going to be, and the payload. And this is just the first one, but I don't know. Well, it can be seen here, but in this one, it's already been covered. There's already space for that, but it cannot be seen. But well, sorry. In this case, it's just the first mock-up, and yeah, I can show you the other one. But basically, we have a different model. It just can be opened for sight, and they can see a whole little space. And when I usually brought to other conferences, and they're like amazed because there's so little space. And when talking with one of our sponsors, they were about the materials, for example, David said, maybe if we use carbon fiber, we only reduce the weight for 3 grams. And we were like, yeah, but 3 grams for me is maybe a backup camera. So, yeah.